According to the Flynn effect, raw scores on IQ tests are rising at the rate of 3 points per year. But even though people are doing better on the raw tests, the results are always normalized so that the population median stays at 100 and the standard deviation remains 15. Below is a table of some raw test scores, and this test was out of 100. We want to transform these scores to IQ scores using the Z value for each. So for each of these, we'll calculate a Z score using the mean and the sample standard deviation of the data. Then we'll transform those into IQ scores. So first thing I'm going to do is I'm going to get a web app here, desmos.com, to help me calculate the mean and standard deviation. I'll just click a plus to add a table. We'll do 40 and all the test scores in this X column. Okay, so now I can come down into this box and type in mean of x1. Okay, the average is 74. And the standard deviation of the sample is 15. Alright, so let's write those things in. Oops. 74 average, 15 sample standard deviation. Now I want to use those to help me convert the raw test scores into Z scores. So the formula I'm going to use here is the X value minus the mean divided by the standard deviation. It's a formula that I had demonstrated in a previous video. I'm just using X minus X bar over S. Okay, so that comes out to a negative 2.27. So this person scored unusually below the mean, more than 2 standard deviations below. The 62 made a Z score of negative 0.8. And I'll just fill in all these Z scores that I had calculated earlier. Okay. Our next job is to transform them into IQ scores. We'll want to use this formula here. X of the IQ score equals the mean that's desired plus the desired standard deviation times Z. So our standard deviation was 15 in the original data, and they still want a standard deviation of 15 for the new data. So this formula right here will do it for us. It comes from the formula X equals mu plus standard deviation times z. That's the formula that I'm using. I'm just plugging in the desired mean for the IQ scores of 100 and the desired standard deviation of 15. Okay, so for the first one, we'll want 100 plus 15 times negative 2.27. This person scored a 66 as an IQ score. The next one comes out to be 88. And I'll just fill them all in. Okay, the highest IQ score here was 124. That corresponds to a z of 1.6 standard deviations above the mean. And what we want to do next is, let's just see if we can show the difference between the normal curves and how we transformed one data set having one mean and standard deviation to a new data set having a different mean and actually the same standard deviation. So let's come up with an x scale and a z scale. So the mean of our original data set was 74, but we want the mean of the new data set to be 100. Now, one standard deviation above the mean for our original raw scores would have been 89. That's 15 above 74. And here we would have had 104. Although since the test is out of 100, maybe nobody can get more than 100. Over here we would have had 59. And 44. Okay, the z's that go with that would be negative 2, negative 1, 0, 1, and 2. What would our IQ score standard deviation markings look like? Well, we got to add 15 to the mean, so 115, 130, 85, and 70. And our z's will be negative 2, negative 1, and so on. All right, so one last thing we might try to do with this is we could create a little bit of a dot plot just to show where the data would fall on the curve. So in a dot plot, you've got a horizontal line, and you try to put dots where the different data pieces would be. So there was one outlier here, more than 2 standard deviations below the mean. That person got a 40. So let's see. We have nobody in this range here, but we do have 1, 2, 3, 4, 5 people fit in this range. One, two, three, four, five, this range. And there was one here. Oh, nope, two there. Okay, so that's where our scores fell. So what would it look like if we did the same thing over here? A little dot plot. It would look the same. As you can see, we have a lot of scores in toward the center within one standard deviation of the mean. That's where people tended to score the most, but we did have some that were, let's see, outside that. And we even had one outlier. The point is, though, it's the same data, but it's a transformation of the data set. All the values still have the same z values, same z scores, but they have new x values now.